Okay, hello students. This is lesson number 5.2. So last time we have seen a linear model that is y equals mx plus b, and we have seen also real life application how to create a linear equation. So this one is 5.2 because some of the real life application would be not in a line, but they will be like a little curve. So this is called modeling exponential function. You can see exponential function relation with algebra. So the learning target is identify elements in an exponential equation of the form. So this is something new now. I can see this. Y is A times B raised to X. And then also we evaluate an exponential model. That means you plug in input X equals a number and you get the Y. Create exponential model with algebra between two quantity variables. So you'll be given 2 points and then you need to figure out what is that exponential equation. You are supposed to graph that exponential model and then solve application problems using an exponential model created with algebra. So each one of these we'll see and straight away go with the main. What is exponential model here? So if you see this, let me go directly to. So here you have full notes on your D2L. It has everything for you to study by yourself. But I just walk through this, understanding what are those each pieces or features. An exponential model here, uh, so of the form y equals a raised to. So the main thing is last time we have seen m times x plus b. So this was the linear model or linear model. Remember that was linear model. And what does this means? It represents a line. So we have seen that if you have x-axis and the y-axis, a linear model is always a line, and you'll be given 2 points. And we remember we had figured out how to model a linear equation where this represents the slope where it goes. Maybe this one goes exactly like going through. Looks like it goes through the origin. It doesn't have to go through the origin. You can have another line, so like this. So where this point is that B and the coordinates is, so the y-intercept is 0, B at B. And you were given 2 points here, x1, y1, and this was x2, y2. And you would see that there is a rate of change. That means for every run for x inputs, so when x increases by some value of x2 minus x1, which is the increase in the x, then the y increases. That means y2 minus y1. And then you take the ratio of change difference in the y's and the difference in the x's, and you get that slope part, which is also rate of change. But in this case, we do not have a line, so it's not a line. But if you have a grid like this, and you have a graph, something like this, this kind of shapes. This shape it goes almost like it comes closer to the x. So this is the x-axis, and this is how it looks like. Means, of course, there are a lot of options here. So I'm going to give an example. They gave you already. What does this basically means? If b is greater than this one is greater than one, we say the model's exponential growth. In other words, if I can create an equation, something like this, and maybe I'll put number, let's say 3 and times 4 raised to x. And you can see this number 4 that I've written down there, 4. So that 4 is greater than 1. That's what it means. And then you have an exponential growth. That means what does it exponential growth basically means? Let's see in Tucson, there is a point, a population in Tucson maybe 1 year since maybe 2015 maybe one like this was 2015 0 year, and maybe next 2016 and 1 year since 2015. That means when it is one, the population may be 450,000, something like that, 50,000. And then in the years, then in 2021, maybe in the 2025, means 1, 2, 3, 4, and 5. Here, this point, the population maybe is 740. So this is how it is. So you'll be given 2 points. That's what it means. It means from 2015 to 2025 is 5 years. So that means when it is 5, so even though this is 2025, but when we are writing the input, we will take the 5. So that means after 5 years, because the population of Tucson was seen maybe here in the beginning was a little less than 450, maybe, I don't know. So, but then in 1 year, let's see, this was the population, and in 5 years, the population is 700 and maybe 40,000. So that's what this basically means. Exponential function means it doesn't go by the same every year. It's like how we have in a line, we had 2 points actually. And then in the linear model, the rate of change means each time you go one, let's say you go one, then there will be something rise. So the rise is the same for every run. So this part. So whatever is here, this was the rise. So this rise stays the same, the height. But if you see in this case, if I go here, this height, then again I go this height, they go on increasing. So they go, so this height is bigger than this height is bigger than this height, and this height is so the heights go on increasing. It means the percent increase, there is a percent increase here. So it's not it's not like in this case, this was like every time you add the same thing, it's like suppose you have 4, and then we have actually 7, and then 11, and then 15, and then 19. You can see here this number they go increase by 3. So you're adding 3 here. So you're adding plus 3, plus 3, plus 3. So that the rate of change is 3. It means 3 over 1 is the slope. For every x increase by 1, the y increases by the same. So this is not the case for exponential growth. So sometimes if this was increases, maybe this increased by, let me clean this. So let's see, let me write this. So in the beginning, from from here to here, let's say there is a little increase. See, and these are not perfect. So this is 1, 2, 1. This is 1. This is 2. This is 3. This is 4. So 1 to 2, little higher, and 3 to more higher, 3 to 4 more higher, and then more higher. So this part is bigger than this. This part is bigger than this. This part is bigger than this. So they go on increasing like so these heights, the outputs, the difference in the y's. You'll see the y2 minus y1. This grows by, it doesn't remain the same all the time. It changes. So when we do the problems, you'll understand what I'm talking about. So the main idea is b is greater than this equation. In this equation, if this b, the base, this is the base, is also called a growth. Now, if b is greater than 1, it is called growth factor. Of course, in this textbook, they gave you, they use the word growth multiplier. See this is growth multiplier. In other words, let's see there was a number in the beginning. We can make a table like this. I think you can understand this way better. So in the beginning, maybe 1 and 2. These are the x's, 3. This is 4, and so on. Okay. In the beginning, maybe it was 3 and 3. Then it doubles. Let's see here, 3 times 2 with 100% increase comes 6. 6 double is 6 times 2 is 12. 12 times 2 is 24. 24 times is 48. And 48, 96. You can see the numbers, but the x and y here, they are multiplier. There's a multiplier 2 here. That's what I'm talking about. So in this example, each time it gets multiplied by 2 here, the b is 2 here. And this 0 means in the beginning it is 3. It means the a, this a that you see, so the a is 3 times 2 raised to x. So you can model the same problem here. Mm. an example to show what does this means, depending on what is that A, B, and C. A, B. So B is, you understood what is B, B means, and A is the, and here when X is 0, the output A, it is called initial amount in the application for starting amount. We also say A is the Y-intercept for the model. It means when X is 0, the point is when X is 0, then it is A. So this is the Y-intercept. So in the beginning, you may get confused what I'm talking here, but as we talk about problem solving, you'll understand far better. Okay. Then they also wrote here why, what about when b is smaller than 1 or it's a fraction? So what I will do is I can take an example of y. So it starts, let's say maybe a is 800. Okay, so let's say there was a 800 times half raised to x. I'm just taking this example just to show that b that you see here, the base, b is the base of the exponential term here, that because it is half raised to x. So even though now here it is, we write this is called exponential decay multiplier. Now why it is called decay factor or multiplier is because, so the b here is half, and half actually is 0.5, and 0.5 is a number between 0 and 1. And that's why the graph, when you graph this, it will not be this way, but the graph will starts at 800 somewhere here, and then it goes on going down, decreasing, decaying, means the graph goes like this. So it comes very close to the x-axis. So starts at 800, and then it then becomes half. Now, what is the meaning of this? B is half is a decay factor, means if this was 800 in the beginning, in 1, it becomes 1, it becomes half of 800, it becomes 400. See? Then again, in another next one, suppose 2, then this is 200. See? This is 400. This is 800. So this becomes, this is the point. So it becomes, so the 2 is half of 400 is 200. And then if you take 3, then it becomes 100 here. See, this becomes, so when it is 3 and this is 100. So this is called exponential decay function equation. The equation is exponential uh, decay equation, where in the beginning it was 800, whatever, maybe it's like uh, there's a pond, and the pond, the lake is filled with all the algae, the green color, and then you treat with some treat with some disinfectant to kill the algae, and every one week you notice that from, if this 800 square feet is the whole, then it becomes, then become in 1 week maybe so much of algae gets killed. Then the next one will be maybe out of this green remaining, this is gone another week, and the next one will be another. So each time 50% goes away. That's what it is. I hope I'm making sense here. Mhm. Okay, so what I'm trying to say is it was 800 right in the beginning, and then 0.5 raised to x. This is the exponential equation with a decay factor. So this is called decay factor. This is the y-intercept or in the beginning. So all this shows you all the explanation. You can read this. Now we'll go use the Desmos. Another way to understand is desmos.com. So on your laptop, we will do also using TI-84 graphing calculator, but we will take directly the one that they gave us in the see example. So if you see this 2 times 1.5 ratios, and I'm going to use this. Mm, uh, Mm. So, so I'm going to use Desmos activity, which it really helps. So go to this one. So this is the desmos.com and you can see the graph here. So y is b raised to x. You can clearly see this is y equals a, sorry, y is a times b raised to x. And now a is the 2, a is in the beginning, it is 2, and you can see this is already 2 here, 0, 2, and b is taken 1.5 here. Now we can easily change this a. If I change this a, uh, instead of a, I think we take this off and add a slider for this. Okay, here a is, so if I put increase this here, can you see this a? So a, if it is 1, that's the point. So this is what, let me use my mouse here. So when this a is 1, this is the y, that's the starting, and then if I change a is to then 1.5, 1, 2, 2.5, 3, 3.5, 4, 4.5. So you can see the exponential function graph, or the graph of the exponential equation. This one, the greater uh, the greater the a is. Another thing uh, I will write is, let me take a new one. I think that's the best way to understand. If I take a desmos.com and click on this open graphing calculator here and type in y is, let's say y is 2 maybe I'll just put 2 times 2.3 point x 3 point 3 point 3 raised to the power. Okay, I can click on this, open this, and you can see here there is that a raised to b. So you click here, it goes up, x, the cursor goes up, and you can put x. Okay, and that's the graph you see here. And instead of 3, let me take it 1.5. Now we can, on this one I can move around it. I want more of this. So 1.5 start with 2. Change this y. You can see that we can change the minimum. This is the minimum and this is the maximum. Let's take maximum as 50. Okay, or maybe 100 is better. So backspace and put 100. Okay. So the point here, when x in the beginning it is 2, so if I click here, and you'll see it is 2, and then 1.5, see 1.5. So the exponential or growth factor is 1.5 here. Now let me type this, a lot of equation like this. Y is 2 times and 2 raised to x. X. Okay. Now look at how the graph rises. Okay. Now let's make it y equal 2.5. Y is 2 times 2.5 and, and raised to x. You can see one more graph there and see how the graph changes the steepness. So the red one looks like this way, but the blue one become more steeper, and then comes the green one. And let's take the last one. This is good to understand by 2 times. This time I'll take 3, close it, go up and put an X, and you can see there is a one more purple color graph. Look how beautiful it is. And then, so the main idea is to understand what does this 2 stands for. This 2, this 2, this 2. is the when x is 0, that's the point. So at this point, when the input is 2, the output is, sorry, when the input is 0, the output is 2. And then the bigger this 1.5 or 2 and this number, okay, or instead I can change this to y equals a, sorry, 2, and then I put a slider b raised to x. Close it, and here I'll put x, and then it says add a slider, just to show that we can always look at this when 1.2 and then the black color goes on changing. See, so that's what that means. The changing b makes it more steeper and steeper like this. But the moment it goes to maybe 2, 2.5, 1.5, and then the moment it changes to fraction, look at this, how it changes to other side, so going downwards. So this is 0.5. This graph is gonna type in here y is 2, then 0.5, 0.5, and then go up x. See, so so I think I put it wrong. This should be 4, right? There you go. Look at the blue color. This graph, or let's change it to something orange maybe. Okay, so this graph orange is 0. This graph is this one. Yeah. Here, 2 times 0. So that means what did we learn here is when the this base b is a fraction between 0 to 1, then the graph is a decay. This is called exponential decay here. Or if I change this slide and make it more 0.3, see, it becomes the 0.2, then become more steeper. And if I try to change, this is how the graph is. So the main idea is this is called exponential decay when it is a fraction. And one more thing is, instead of this a, if I change this, let me fix this. Let me take off mm, all of them and make it 1. Let's see what happens. Let me remove this. Okay. And now I'm going to make it -2. So outside I'm making -2. No. So what do you see now? Look at the graph. They go this way. There is a reflection over the x-axis. So the one that we had in the earlier it was going upwards, and you'll see these graphs are going down. So when the initial point is a negative, if there is a negative outside, so there's a reflection over the. Let me show with the help of. Let me show this one. Here it is. This was the graph, right? So the red color, so this graph that you see is a reflection of over, so this is a reflection over like this somewhere here. So this was the graph y equals 2, and I think it was 1.5 raised to x. Yeah. Then the blue color, this blue color was this one, this reflects down, see. Then the green color, so the green color was this one, so the graph goes down. And then the purple color is this one, goes this way. So this is a reflection. So I hope I'm understanding. The goal is if y is 2 plus here and it is 1.5 raised to x, this graph is like this, okay? But if it is y is minus 2 times, so if it is negative, and the graph is it's the same thing but reflection downwards like this. So this is the understanding. Okay, let's go directly to the examples and see what's given as the I wanted to show here. Okay, so what did we learn here? So what did we learn here is the main thing is this one, right? 1a equal b raised to x. Now there are two parts. One is if a is greater than 0 and if a is less than 0. So with the a is greater than 0, then there are two parts again. Depends on b if it is greater than 1 or if it is b between like this. So this graph, because it is positive. What is this means is positive. So even when the first number is positive, and this is greater than 1, then there is exponential growth like this. But if the base is less than 1, then there is a decay like this. This is what that means. Now the same thing here also you have two parts. If b is greater than 1 and b is between, so here you have in this example how the graph will look like. Now, this basically means A is a negative number. Okay. So if A is negative number, maybe Y is minus 3 times 2 raised to X. So what's going on is the graph will be this one. So instead of exponential decay, it is a reflection of if this was without minus, then this is with minus. And this one is because there is a fraction. So if this was this one, because this is a exponential decay, but because of the minus negative, this graph goes like this. This is how. And let's now go and check what's going on. I know at this time, as I'm explaining or demonstrating you, you may got confused. Why don't we directly go to the problems? And the packet you have, open the packet. The first one says how do we know which is the exponential function? So the first question is pretty easy. So among these, you have four examples. So which among these is exponential? How do we know which is exponential model? See, this is the question. Exponential model, remember, you have to have something A and a B, and this B, always remember this B has to be greater than 0. You can't have a negative. And there's also, it should not be 1. So the main reason is when you can't have like this. This is wrong. This doesn't become exponential function like this. Or you can't have y equals 4 times 1 raised to x because 1 raised to x will reduce to 4 times 1, which is 4. So that y equals 4 will reduce to a kind of a line or a cross line through 4. So, so this will be the horizontal. It's not going to be a exponential raise or exponential decay. So that's how you have to know that whenever to define exponential function, exponential equation or this, you want to make sure this b it has to be greater than 0 and it should not be 1. And second about this b, it should not be it could be 1 also. No, so this A could be any real number. So there is no restriction on that. So the main thing is this B here. Now the first part is see y equal. This is 4 times x raised to 1 plus 0, which looks like an exponential. I mean, sorry, this is linear model. So it is like m of x plus b. So this is not the exponential model. We want to know which are the one, right? Look at the next one. Is y is 2 raised to x. Now there is a degree 2 say this x this is a monomial. Remember polynomial or monomial. This is a monomial because it is of the form some number a times x raised to uh, m or p, where this should be real number. This should be integers. I mean, it has to be positive integers. It can be zero also, but integers. So here this is 4, which is a degree, and this one is it is a polynomial, which is also called a quartic. You can also see the graph. It will look like this. But because it is x raised to 4, just by x raised to 4 is going to be like this. The x square is something like this. But this one, it flattens over here and then goes like this. Anyway, the goal is to know which one is the exponential. Let's check the third one. Now, the third one is y is 5 raised to x. And clearly this is b. b is 4 and it is greater than 0. And 4 is not 1. So this is exponential model. What about this one? Now this one is greater than 0. And also you can see this b, which is 4, b is greater than 1. So if you want to see the graph of this, there is an exponential growth. So it goes like this through 4. So start with 4. Okay, whatever the point 4 is, and then it increases, percent increase. There is increase is 300% because 4 can be written as 1 plus 3. See, so whatever you have 4, and then you add 3 times whatever, that is 300% increase. Anyway, we'll see that. The next one is y is 3 plus times half raised to x. So here this is b. So the b is half, and this half is greater than 0, and half is not 1. So this is exponential equation, and it is also because half is between 1 and 0. So we can say that this one is exponential decay. So what it means, it starts at 3. It means it starts at this third one. Y is 3. So what is this basically means? It is 3 times, it is 0.5 raised to x. We can also write this as 1 minus 0.5, just to show what is the meaning of what percent it decreases. So this is 1 minus of 50 divided by 100. See, I can always write this is 3 into 1 minus 50%, say, raised to x. So there is a 50% decrease, or there's exponential decay. Exponential decay factor is 0.5. This is, and how much it decreases? It decreases by 50% each time, whatever that is 3. Suppose there was a 3 was the beginning. So if 3 was the beginning, the next one is half of 3 is 1.5. And then the next one will be 1.5 becomes 0.75 like this. And likewise, it goes for every input increase in 1. So the output 3 goes. What I'm trying to say is, if you have, if starts with 3, if this is the 3, let's say this is 3, this is 2, this is 2, this is 1, and each time you increase, so in the beginning it is 0, this is 0, 3, and when it is 1, so half of 3 is, so half of 3 is 1.5, so this is that 1.5. See, so this is the point. Then 1.5 is 0.75. See, I can break this, and this is 0.75. So when it is 2, it becomes here. So this is 1 is 1.5, 2 is 0.75. If you want to know the another one, 3 here, and half of 0.75 is 0.375. See, like this. And that's how you have a point. You can see there's a graph, and the graph goes like this. See, pink color. So there is a percent decrease, decreases 50% decrease, And you can see this 3 become 1.5, then becomes, so that's what this, so they don't go down by the same number. So in the beginning, it goes down from 3 to 1.5, but from 1.5, it doesn't go that much down. So from here, there is a drop here, but here the drop is less. From here, the drop is little less, and like that. So I hope I'm making sense here. See, this drop is so big. This drop is not that big. This drop is still less than whatever this was. So it's always half of what was before. Okay, so let's move to the next question. Okay, so you could just do it by yourself, but still check your answers. I want you to pause this video and do it yourself. Which of the following is an example of exponential model? And if it is an exponential model, identify, oh, we have to also identify y-intercept and the growth multiplier. This growth multiplier or this growth multiplier can be growth factor. We also call this uh, growth growth factor, or it is also called decay factor. So what is decay factor? Basically means when the b is between 0 and 1. Okay, and growth factor is when it is b is greater than 1. And when you talk about growth multiplier, this basically means what is that eventually multiply all the time. Let's take an example. This piece, if you see, y is 200 times. Now here the variable is down. Look at this. The base, the bottom part is the base. This is the variable, okay, and this exponential part is a number. So this is like a variable raised to a number. So is not. This is not. So this is cannot be because this basically is a polynomial or power function also. It's called power function. Later on you'll see if you want to do more maths called power function. But because this is plus 5, because it is a integer, so because it is an integer, we can call this a polynomial function also. So polynomial function is basically when the degree, the highest exponent that you see is 5, which is also called quintic function. So anyway, so this is not the one. What about this piece? Yes, so this one is 200. 200 is the y-intercept, okay, clearly. So this is the y-intercept, the initial point when x is 0. And this part is the exponential growth multiplier. Yes, 5 is a growth multiplier. So this is a growth multiplier. But in this case, this 5 is, I will say, because it is greater than 1, I call it growth factor also. Growth factor. So growth multiplier, when each time you multiply by 200. That means in the beginning it is 200. So 200 changes to, so this is how it is. You can make a table out of this and say, okay, this is 0, 1, 2, 3, 200. 5 times 200 is 1000. 5 times 1000 is 5000, and 5 times 5. So each time you multiply by 5 and becomes 25,000. See? So that's the understanding piece of that problem. Next is K. So now you already know what to do, right? So this is Y is, and there's no number. So there's the 3/4, 3/5, and there's no number. It means there's a 1 in the beginning. That's what. So if you want to make a table like this, in the beginning, this is the input, output, X and Y. So when X is 0, it is 1. And when it is 1, 2, and like this. So when it is 1, it will be, if I put X equals 1, this will be, so this is again, this will be 3/5. And you can see the variable is not, yeah, this is variable, the exponent is a variable. This is exponent. So this is exponential model. This is exponential model where in the beginning it is 1, which is the y-intercept. That's what it's asking. Identify the y-intercept value. So when you compare this to a times b raised to x, so the a is b. So a is 1, the y-intercept value, which is the y-intercept, and the growth multiplier is the b, which is the 350. 350. Now, because 350 is less than 1, I can call this is also exponential decay factor. We call it decay factor. Decay factor. So that means the number, so the graph is going to be something like this. See, if we have x-axis and y-axis, it starts at 1, right? So maybe this let's put it like 1 here. So this is like 0, 1, and then become 350. So each time you do one, so whatever the one here is, if I break this into 5 parts, so the one it becomes 3/5. So this will be 1/5, 2/5, 3/5, and this is 4/5, and then this is one means 5/5. So 3/5 basically this is the hard. And then again graph goes like this. Okay, next one. So D, if you see here, there's a y is 4, and the parenthesis, the number that you see is -2. See. So that means remember if when you compare with the exponential equation b raised to your main condition is this has to be greater than 0. You can't have b cannot be negative. Okay. So because b is negative, this is not exponential equation or not exponential model. So this is not exponential model. Okay. And the last one is a line. So this is 3x plus b, which is y equals mx plus b form, right? So this is linear model. And why it is linear model is because the b it is x raised to 1. So the degree here is 1. So that's the line. It's just a line. Let's go to the next question. Okay, so this is example number 2. All you need to do, example number evaluate. Evaluate basically means you plug in. What are you plugging in? Plug in the value of x. So based on what? So the first one says plug in x equals 2 in the exponential model. It is 5 times half raised to x. Okay. So x is replaced by 2. So this becomes y equals 5 times half raised to 2. So this will equals 5 times. So this becomes 5 times. Now, what is the meaning of half raised to square? This basically means this part, which is the base, is multiplied itself 2 times. So it is like half times half. And 1 times 1 is 1, 2 times 2 is 4. So this becomes 1 over 4. Or you could say because there is a 1, this 1 stays 1. All you do is this the bottom 2. Because there is a 2, you just multiply 2 times 2 is 4. See, that's how you get this. So eventually your answer becomes this 5 means 5 over 1. And then multiply the numerators with 5 times 1 is 5 and 1 times 4 is 4, and you're done. So this is the answer. But if you want, you can use the calculator, or you can also change this with the calculator. You can 1.25. So your point becomes when it is x is 2, it is 5/4. This is your final answer. Or you could also write 1.25. I want you to also, since we are using TI-84, to put this just to get used to the calculators. So if you see this calculator that you have TI-84, yeah. So here you can type it was 5 times. So click on, you put it on, and then click second mode, and then you get a blank screen. And then since there is a 5 times, so 5 times, and the open parenthesis, and is the 1 divided by 2, close it. And then there is this V shape which is inverted. Click on this to take it exponent. And because they're asking you to, so just put a 2 and you enter. You get the answer 1.25. But if you want to know how does to change into a fraction, you can click on maths and say, okay, you want to write in to fraction. So you want to change the fraction FRAC, and then you enter, you get, and again enter. You see, you get 5/4. So both are correct. So this is like changing from decimal to fractions. As and when you are using this, or you can use your Desmos calculator also. So this, I can refresh, reload this. So you can use your Desmos calculator also. And the same thing, see, there's a keyboard here, click on it and just type in 5 and open parenthesis. And you want to put 1 divided by 2 to get the base, close it with the parenthesis and go up. Not this one, I made a mistake. So let me go delete this. So you go up, okay, and go back and then close it and then go up, put a 2 and you get the answer, see, 1.25. This one, I don't know how it gives you in decimal, not the fraction. Hope I made sense. The next question was asking you plugging in, let's put x equals 5 there and see what's happening. So I'm spending this time. If you understand, you don't have to watch the video. You can directly go to the next one. So the second time you're plugging in 5 here. So your y equals that this 5 stays, multiply, and there is half raised to 5. See? All you write is 5 times. Because this is 1, no matter whatever 1 raised to 5 or is same as 1 raised to 6 doesn't change 1 raised to 4 because 1 multiplied by 1 is 1. 1 multiply 1 is 1. See, it doesn't change. So this is 1. The bottom piece is 2 raised to 5. So the question is, what is 2 raised to 5? So 2 raised to 5 means you are multiplying 2 itself 5 times. That's what that means. So 2 is multiplied itself 5 times. 2 times 2 is 4. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. See? So this answer you get is 1 over 32, which we can write it as, because 5 basically means 5 over 1. So 5 times 1 is 5. And 1 times 32 is 32, and you're done. Okay. So if you want to use this, the TI-84 that we have, you can write 5 times. So it is 5 times, open parenthesis, 1 divided by 2, close, and then go up and put 5. And I think it gives you into the decimal, and then you want to change this to fraction, so you can click on maths. There is already a fraction, so enter, and then you have to, because this is the answer, has to be changed to fraction. So you click one more time, you get 5 divided by 30. Or you can use Desmos calculator also. So instead of this, I backspace and put a 5, you get the answer. There it is, 0.156. Hope I made sense. Let's go to the next question. Okay, now comes a model with the real world problem. So the population of India was 1.3 billion in the year 2021 with an annual growth rate of 1%. This situation is represented by the exponential model P. So this is the middle given to 1.39, 1.01 raised to t. So they already gave us the exponential model where t is the number of years since 2021 to the nearest thousand. what will be the population in the year 2030. So I want you to also understand this. And the question also, some of you may be thinking, how did we get this equation, right? So main thing is, I'll try to make a table to just to make a quick understanding. And the year was 2021. So this is 2021 is the start, right? So that's like a 0 year. That's the time you wanted to model. And we use T is number of years and P is the population. So in the beginning it was 1.39 billion. And of course 1 billion is 190. See? So this is what actually the 1 billion is. So in the beginning in 2021 they gave you this population. The population in the maybe 2022 in 1 year it grows by 1%. So 1%, what is the meaning of 1%? Means 1 out of 100, which is 0.01. That means there is that growth factor, some number gets multiplied. What is that number multiplies? That's this piece. If you compare this y equals a raised to b raised to x here, this b is that 1 point. That 1.01 is basically the 1 in the whatever the um, population in the 1 year before, and then you are adding to it a 0.01. So this is like 100%, whatever the whole population, and this is adding 1% means 1%. See, so it is like 101, or you can write also 1.01 as 101 divided by 100. You remember that what we did earlier in the last chapter number. So the idea is this, but we don't want all this scale. We don't have to show. They only want what do you think in 2030. So like this is 22, 23 to 23, 24, 25, 26, 27, 28, 29, 30. So this is what 2030. So how many years pass from here to here? So 2030, and if you subtract 2021, how many years have passed? 9 years. So that means what is the population from here to here? 1, 2, 3, 4, 5, 6, 7, 8, and 9. See, that's what the population we want to know this piece. So all you do is plug in this equation that t is how many years passed since 2021 is 9 years. So on the calculator, remember 1.39 has to be plugged in. So the main thing is 1.39. Let me see if I can hmm, get, so let's go back. And where is the calculator? So here 1.39. So we have 1.39 times, open the parenthesis, 1.01, close it, go up and put a 9 and you get the answer. Enter. So you get this answer, 1.52. So we can round it to 1.5202, 4 place decimal. So remember this answer is 1.5202. So the population. So let's go back to your. So the answer here is okay. So how do we show this? Nice work is y is 1.39, and remember your x is 9 years since 2021. So all you do is 1.01 raised to 9, and when we use, we got 1.5 on the calculator. You got like this. And we can round it to, because this one was 1.39, so I'll write 1.502 billion. And you're done. That's all they're asking you to find out. So I think I missed a two here. So the main thing is asking to the nearest thousandth. Now, what is that thousand means? This is 10th place. When I say this, 10th. If you see this is 100th. That two is 100th. 100th. And this number is thousandth. And because it is 1,000, even if we had to write only this was enough. But then we took one extra because to avoid rounding error. So we could be using in future sometimes when you're calculating, you may need this to avoid more. I'll take one more decimal here. See, so three places was enough, but we rounded to this one. Now, solve. How do we solve equation this? So this one gives you an example of how do we solve this. The way they show, it looks confusing, but I'll try to show with some example. Let's see. If you have 5, 25 is x squared. So what does this basically means? It is x squared is 25. Now what we do is we want to know what is that. We can easily see what multiplies itself to give 25, and clearly we know the answer. But only thing we want to know x has to be positive. So what are the number that multiply to give 25 is 5 times 5 is 25. So we say x equals 25. Now instead of this, we use another second method, and that is if you have this, the next step you write everything the same. Okay, so you write, if this was the case, instead of this, you write x everything the same. Only thing is you put parentheses and write down a raised to u raised to half times half c. So both the sides you raise to half. Now this basically will be x raised to 2 times half is this one stays the same. Of course, and this 2 crosses out. So you get x equals 25 raised to half. Now what is the meaning of this is it is the what number multiply itself to give 2. This is what it means. Also it is written as square root of 25. And you know the answer is 5. But not all the time it is possible to get this. So let's take another example. If I have x raised to 5 equals 53. So the best way to find x is you put raised to, because there's a 5, you just do the opposite. This is 5 over 1, you do 1 over 5 both sides. The calculator does the job. This 5 crosses out, and you put this on the calculator 53 raised to 1 over 5, and you get the answer. Let's take another example. If we have x raised to 7 is 40. Okay. So how do we solve this? How do we figure out x? All you do is you raise this by 1 over 7, 1 over 7. And then this 7 and this 7 crosses out, you get x equals, put this on the calculator again. Or sometimes you may have x equal 5 over 4, equals 9. So how do we find x? All you do is write that x equals 5 over 4 one more time, both of these, and raise it to the power, what, do the opposite of 5 over 4 reciprocal, which is 4 over 5. So this also becomes 4 over 5. So this changes to 5 4 times 4 over 5, and this is 9 over 4 fifths. Now 5 over 4 and 4 over 5, they cross each other, so this crosses, you get x. The goal is to isolate, the goal is to just to get an x. Now this piece 9 raised to 4 fifths. We can easily find with the calculator. So if I go, if I use this calculator and I want to write 9 raised to 5 fourths. So type 9, then go up, and then you can do 5 4 directly with open parenthesis. 5 divided by 4, you get the answer and close it. And there you go. Or you could also do 5 alpha equals, and you have that numerator denominator, enter. Then I messed up. That's clear. I have to type 9. I want to go up alpha to get the means enter. I'm getting 9. I put 9, then go up. Oh, it goes up. And then I want to write alpha, like actual fraction. And we put 5 4. Go down, put a 4. You get the answer. See? Anyway, and if you put out the this calculator also you could do, and you can put 9 times 5. Put a open, this is better to put. And then since it was, oh, 9 raised to, go backspace. So I'll delete this. 9 times 9 raised to, so you go up. And here you have to put parentheses. 5 divided by 4. You get the same answer. See? So two different approaches. One is using TI-84 and another is using the Desmos calculator. Let me go directly to solve the next problem. Okay, here it is. So this is example number 3. It's a given 2 points are given. See this? And find an exponential model. So the main equation is y equals a times b raised to x, right? So since you're given 2 points, so the first point is 0 and 3. So let's plug in this x and y. So step number 1, you plug in y is 3, the red one, see? So I put 3 equals, a is stays the same, b stays the same. Our goal, what is our goal? To figure out what is a and what is b. So x is 0. So this piece which you see the black color, this x is 0. So I put as 0. But anything raised to 0 is always. Remember there is the laws of exponential, laws of exponential. Exponent says, so as and when required, I'm going to show anything raised to 0, b raised to 0, anything raised to 0 is always 1. Okay. Of course, there is a lot of explanation why, and because of the time, I don't want to add this. There is a nice two ways to show why it is b, anything raised to 0 is 1. So this is 3 into 3 equals a times 1. See? So that means a times 1 is a. So you already got a equals 3. Now this piece will go right here. So the step 2. So step 2, this was step 1. So step 2, we got the y is a, which is the 3 times b raised to x. So our next goal is to find the b. So the b is question mark, right? So we're going to use the second number. Plug in 338 in the exponential equation. So let's exponential equation. So this one. So this is the one, right? Of course, it was this. Now that we got already a, so we got to change to this. So let's plug in x and y. So the black color, the red color, let's use, this is y. Y is 3, 8. So this y will change to 3 equals, okay, so you plug in y is 3 8, so it is 3 8 equals this 3 stays the same, and b raised to x, and x is this one, the black 3 is 3. Now to solve for b, it's better to multiply both sides. Because there is a 3 over 1 here, I'll do 1 over 3 times 1 over 3. So this 3 and this 3 crosses out, and what I'm left with is 1 here. 1 times 1 is 1, and 8 stays here, equals this 3 crosses out, and you get b raised to 3. Okay. So this is what. So earlier I showed you an example. This is as good as writing b raised to 3 is 1/8, and then you raise to the power 1/3. That means because this is 3, you do 1/3 this side and you do 1/3 this side. So what you get is y equals, because b raised to 3 and 1 over 3 basically same as b raised to 3 times 1 over 3, which is the b raised to 3 over 3, and that is b raised to 1. Or we can just cross out here and you're done. This is because your exponential laws of exponential, if you have b raised to m, this is b raised to m times n. And that's what I did here. So whatever that number, you just multiply. So this crosses out 3, 3, and you get b equals 1/8 raised to 1/3. Of course. So, but this one was an easy number that you got, because what is the meaning of 1/3? Means what number multiply itself to give 1/8, and you can see the answer is going to be half. So you may say, hey, why? So the reason here, if you put on the calculator, you'll see, but it's better to know also why it is. So why it is half is because when you say 1 over, what is the meaning of this? This 3 is that it's like saying, hey, what number multiply itself to get 1 over 8? Because there's a 8 here. And the only way to get 1 over 8 is it has to be half, half, and half. See? That's why it is half raised to. So because there are 3 halves, so you raise half raised to 3 is 1/8. And that's why you say half is 1/8 raised to 1/3. So you may get confused a lot, but as I always said, you don't have to worry. Just directly use the calculator. See, if you have like this one, and you go here and just type in here. Okay, you write, it was, put parenthesis 1 divided by 8, close it, and then go up, and I think put 1/3, right? So here it is. I put 1/8 raised to, and then I have to have 1/3, which you can put alpha this, enter, and put 1/3. So there is already up, and you put 1 divided by 3, and you get the answer like this. I think I messed up. Let me see, what did I do mistake? Oh, I think I forgot to go up. So if you have it, you can go backspace and enter and edit it. So go back here and go up, back, delete, go back, delete, go down and put 3 and enter 3.5, which is half. So if you change to fraction, and you get half. So I hope that makes sense. Let's go to the next one. So eventually you got b equals 0.5, which is also half, right? And you got 3, so the equation y equals a times b raised to x. Now the equation is y is 3. 3 is the beginning, and then it is 0.5, or you can also write half raised to. So I'll use fraction half raised to x, and we can put this on the calculator and see what's happening in both cases. So let's go and put in the Desmos. And put y is 3 times half, close, go up, put x. I think I got make a mistake over this one, and then you right click, and then close, go up, put X. Okay, and you can see it starts at 3. That's how the graph is. And you can also, the second point that they give was 3, right? You could put this a add a table and put 0 was what was 3. The next one, 3 was, oh, they gave us a fraction which is at 3/8. So this is that 3/8. So this is that 3/8. See, sorry. So if you see here, this is the 3/8. So this was given to you 0 and 3, and this was given to you 3 and 3/8. But 3/8 is 0.375. You can see there's a nice exponential decay. Y-intercept is 0, 3, and that's how the graph looks like. And I hope that makes sense. But if you want to use the other calculator, uh, where is out? Yeah, yeah, yeah. So if you want to go click on y equals, okay, and you can type it was 3 times. So type 3 times, and then I'll better to put alpha this to show that it is uh, half. So 1 go down, put 2, so you get that half. I think I forgot to put 1. So go up and put 1. So you get that, and then you right click one more time. You go here and then go up and put an X. And then I will use window, which is or zoom, put standard, which is 6 here, and then graph. See, you can clearly see the graph here. Uh, and also you can find out for any value. If I want to find for 2.3, let's see, if I want to know what is 2.3, you can say calculate, second calc and value, enter, and you want to put 2.3 and enter, you get the answer. So let me pull this, sorry, mm, 5.2. So we finish with example number 4, then graph of exponential function graph. So in example number 4, you see these are the 2 points. Among the 2 points, the first point is -2, 6, and the second point is 2, 1. So each time you plug in the equation, exponential form function a times b raised to x. So plug in x and y. So that will be 6 equals a times b raised to -2. So this is the -2 for x. And the second time you plug in, this is x and y. So y is 1 equals a times b raised to 2. Now, what you do next is, this is equation number 2. This is equation number 1. So next step is divide equation 2 by equation 1. So write the equation 1 as it is, a times, and then divide by 6. This is 6. And then we can cross out the BAA crosses out, and you get 1/6 equals. Here we can use, if we have B raised to m divided by B raised to n, this is called quotient of power, the same as B raised to m minus n. So if this is 2 and this is minus 2, we can write B only once. It is 2 minus of minus 2. So that becomes 1/6 equals B raised to 2 negatives mixed with positives, and 2 plus 2 becomes 4. And then we need to figure out how do we find now B raised to 4 is. So again, let me write this here. So B raised to 4 is 1/6. So now you raise both this and this by 1/4. And the reason is we can cross out the 4 and a 4. What stays is only B equals. B equals 1/6 divide. So this is what you have to plug it in the calculator. Let's put it on the calculator. So 1/6. So put parenthesis 1 divided by 6. Close it. Go up, and it is 1/4. So 1 divided by 2. You can see, and then enter. And you get 0.4. I think it is 1/6 divided by 1. So I'll go back up here, and we need to edit this. Go back. This is 4. And you get 0.6389. So go back to this one, and this is 0.6389. So the equation now will be see, this was the original equation. So this will be A is, so the equation is y equals A times, and B is 0.6389. And then I put X. Now our next goal is, so this A, B is done here. Now our next goal is to find this A. So we can again use this point or this point. So I will say let's plug in 2, 1 for X and Y. So it becomes 1 equals A times 0.6389 raised to X, but X is 2, so this is 2. And then both sides divide by this one, 389. So you divide both sides by this. Okay. And so this crosses out and you get A equals. Let's plug this in the calculator and see what we get. So it is 1, or you can click on alpha this, and make this small. And then the numerator is 1, click down, and the denominator is there's a 0.89, so 0.6389, 6389, close it, go up to 2, and get 2.449. So we get 2.4498. Let's go back there. So 2.4498. So the final equation will be, so now that you have both A, so the A is 2.4498 times, and the B is this, and then you put raised to, so this is your final equation, raised to X. You can put this in the calculator and see how do we put this in the calculator? Mm, Click here, y equals, so it was 2.4498, 2.4498 multiplied, and then it was open parenthesis 0.6389, close, and go up to the X. Yeah. And that's graph. Window, we will zoom in the standard one, that is Z standard. So click 6, and you can see the graph right there. And the 2 points, if you click trace and click on -2, and that's the answer. See, it is 6. And if you want to do another point at 2 and enter, you get that 1, which is 0.99, which is almost 1. Or you can click on table and just click on -2. So it's the first one. Click, or you can go back also -2, which is 6. And you can go down and check for 2. This is for 2 is 1. And -2 is 6. Or if you use the calculator, Desmos calculator, okay, and cancel out all this and plug in y equals 2.4492 times 0.6389, and go up and put an X, and you can see the graph right here. You can also use the table to understand this and put -2 is 6 here, that's -2, and 1 is 2 is 1. So this is what the understanding is. Hope that helps. Let's do another one. So in this example, it says 1 and 2 and 4 and 7. So 1 and 2, So 1 and 2, so x and y. The second one is 4 and 7. So each time you plug in x, y. So the equation is y equals a b raised to x. So plug in y is minus 2 equals a times, and x is 1. So this is one equation, and the second time, uh, so you plug in y is 7, so 7 equals a times, and put x equals 4. That's the second equation. Call this as 1, divide 2 by 1. So the second equation is 7 equals a b raised to 4. And the first one is minus 2 a b raised to 1. So you get, I think it's 7 over plus 2. There is no minus. It's just a 2. So this becomes 7 over 2. Cross out the a. And this 2 will be b raised to 4 over b raised to 1 is, actually it is, there are 4 b's multiply. One of the b crosses out, so there are 3 remaining. And that's why the formula this is b raised to 4 minus 1. So this little numbers are multiply exponents and you get that answer. So this becomes b raised to 3. And now you have to do raised to the power. Both of these numbers has to be, because it is b raised to 3 and we want to find b, and there is a 3, so you multiply raised to the power of 3, 1 over 3. So this 3 crosses out and you get b equals, and the calculator does the job. So 7 over 2, 1/3. From the calculator, let's put 7 over 2, 1/3. Clear everything. 7 over 2, so I'll put alpha equals, enter. Then it is 7, go down, 2, go up, and 1/3. Sorry, 7 over 2, right click, go up, and again fraction. So it's better to put I'll put a open parenthesis. So this helps to understand. And then when you go up here, put 1/3. And you get the answer 1.518. Round it to fourth place to 5183. 1.5183. Okay, so this equation which was here, now we can write it as y is a times 1.5183x. We can plug in any of this point. I think this is better. So let's plug in this. Plug in. So y is 2, and a is what we need to figure out. And this is 1.5183 raised to x. X is 2, 1. So to solve for a, divide this by 1.5183. Because this one will make it the same number. So this is 1.5183. So this crosses out. Put this in the calculator. You'll see you get a equals 1.3173. So your final equation becomes y and this is 1.5183 raised to x, and you're done. So that's the exponential model where this is the initial point and this is the growth vector or exponential growth factor. Now, if you want to graph this, let's graph this and see how does the graph look like. Turn the Desmos first. Uh, Take this. So y is 1.3173, and this point is 1.58. And see, I can add a table and put those points, and the points were 1, and the other one was 4. So where is 1 and 4 is here? 1 and uh, oh, this one is 5183. So this is to 5. Okay. So this is 1 and this is 4. So 4 is 7 and 1 is 2. So hope that helps. You can put the same thing in the calculator in the here also y equals. Clear this and I can go delete and put 1.313 times 1.5183. Close it and go up and put a x and graph. Did I make a mistake? Oh, I think I forgot here to put the x. And now graph. See? There you go. And if you put x equals 1, trace, put x equals 1, enter, you get that 2. And if you put 4, enter, you get 7. So those are the points on the exponential graph. Okay, before we go to the next example, it is better to know what is the meaning of this 2 raised to x. So what does this basically means? We can do x and the y. So this is x and this is y. And each time we can plug in some numbers. I'll put 0 here, -1, -2, and -3. And then 1, 2, and 3. So let's plug in x is 1 here. So y becomes 2 raised to 1. And 2 raised to 1 is 2. So that means the answer is 2. If I plug in x equals 2, so this will give 2 raised to 2, and 2 raised to 2 means 2 times 2, which is 4. So this will be 4. If I plug in 3 here, this will be 2 raised to 3, which is 2 times 2 times 2. So you multiply 2 itself 3 times, that becomes 8. So this is 8. If I put 0, that becomes 2 raised to 0. Anything raised to 0 is 1. Okay. Now next you put x equals -1. So this will be y equals 2 raised to -1. By negative exponent property, this is 2 raised to 1. So this is 1 half, which is 0.5. So this will be 0.5. And when x is -2, so y will be 2 raised to -2, which can drop down as 2 square, which is 1/4. And 1/4 is 0.25. So, and so on. And then we can graph this and make 1, 2, and 3, 1, 2, and 3. And this I'll make a smaller kind of thing. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So when we have x equals 0 is 1, so 0 is 1 will be this point. 1 is 2, so 1 is so 1 is 2. See, this is 1 is 2. 2 is 4. So if I go this way and this way, that becomes 2 is 4. And 3 is 8. So 3 you go up all the way at this point. Minus 1 is minus 0.5. This is minus 1. And minus 0.5 this one. And you can see we can graph. And then we can graph this like this. Hmm? Passing through all these points, and you have a nice smooth exponential graph like this. And this number almost goes closer to 0, and that's why we will see later on that the green graph approaches almost like y-axis, x-axis, and that's why we say x-axis here is also called horizontal asymptote. So what is horizontal asymptote? Asymptote means that if x approaches like this x approaches to a very large negative number, then the output, this output, remember this was 3 and 8. So 8, then it was 4, and then it was 2, and then it was 1. So the outputs 8, 4, 2, that 1, and then they could become very small, but they never become 0. They approaches to 0. So now the next question is, what about if the same equation, there was a 3 here? See, instead of this, it was 3 times. So for this, let me take this off. So each of this is multiplied by a scale factor of 2. What that means is, if this is 1, this 1 gets multiplied by 3, this 3. So 3 times 1. Yeah, okay, yeah. So anyway, the point I'm making is, if your original graph is y is 2 raised to x, so this graph is like this, then y equals 3 times 2 raised to x means every output gets multiplied by 2. So if this was 0 and 1, so this 0 and 1 becomes 3. So it goes to 0 and 3. And if this point was, let's see, 1 is 2, so the 2 gets multiplied by 6. So there is a 3 here. So 3 times 2 is 6. So 4, 5, and 6. Okay. So this is how the graph stretches by a scale factor of 3 like this. So I hope that makes sense. So let's go directly to do example number 5. And this time you have, so how do we graph this one? Graph y equals, but this time it is 3 raised to x times. See, there is a 3 raised to x. So we can do this. We'll pick not many points, just few of them maybe. Is 2 times 3 raised to x. So before that, I'll do another column just to show. Let's do only 3 times x. And the next one will be 3 raised to x. And the next one is 2 times 3 raised to x. So this is x, and this is not y. First part is only this, but this is y equals the output. So let's take only few points, 0 maybe, and -1 and 1 and 2. So this we'll see what's going on. So 3 raised to x. So if I plug in here 3 raised to 0, first of all, when x is 0, it is 3 raised to 0. So anything raised to 0 is 1. And then multiply by 2. So this becomes 2. So 0 is 2. So the point that we get first is 0 is 2. Then you plug in this one. So 3 raised to 1 is 3. And because there is a 2 here, 3 times 2 is 6. Then you plug in 2, this becomes 6. 3 threes are 9, and 9 times 2 is 18. And minus 1 is 3 raised to negative 1 is actually, it is uh, 3 raised to negative 1 is, in the positive form, it is 3 raised to 1, which is 1/3. So I'll just keep 1/3, and then we can graph this. So your points are minus 1 is 1/3. So if this is minus 1, so minus 1 is 1. Suppose this is 1, then 2, then 3, then 4, then 5. So the few points we can mark. So 0 is 1/3. I think this is 1/3, but then because you're multiplying by 2, it becomes 2/3. So minus 1 is 2/3. So 2/3 will be this one, and 0 is 2, 1 is 6. So your graph is like this. This is how it looks like. You can easily check this with the help of also Desmos calculator. Uh, can take this off. Let's put y equals uh, 2 times 3 to the power x. See the graph? We can change this setting to see more of the y. And instead of this y, the maximum 7, we can put 25 maybe. Or you can put 100 just to see the whole thing. Look how beautiful it looks. There it is. And if you want to add a table, you can see all this point from -2, whatever the point is. I have 1, 2, 3, and I can put another 1, 3. Okay, so these are the point. This is 3 is 54, 2 is 18, 1 is 6, 0 is 2, and like that. And that's 2/3. This part is that 2/3. Remember? So hope that helps. Let's go to the next question. So next question is, how do we graph this one? Graph of 10 raised to half. Okay. So graph of y equals, now you can see here, if you compare this with exponential model, you can see the b is half, and which is a fraction, which is less than 1. And that's why this will be exponential decay. So we are going to take only few points, not many, exponential decay. And to graph this, always try to put x equals 0. So we'll take the point main is x equals 0 and 1. So suppose this is x and this is half raised to x. See? Half raised to x. And the next one we can think of 10 times half raised to x. That's the y. Okay, this is the y. So when you put x equals 0 here, that means half raised to 0 is 1. So this is 1. And because there's a 10 multiplied, you write 10. This one is half raised to 1, which is half. So this is half, this is half, and multiply by 10. So if I multiply half of 10, which is 10 of 10 divided by 2 is 5. So this becomes 5. If I take 2, so half raised to 2 is 1/4. Half times half is 1/4. And then you multiply by 10. So this is 1/4. Multiply by 10, you get 10 by 4. And 10 by 4 is 5/2 by dividing by 2 both sides. See? dividing by 2, get 5 by 2. Or you could do from here itself and you just say, because you already know this is the decay factor. This is the decay factor. B is the decay factor. I mean, every time if this is a number, the next number is 5 by 2. The next number is 5 by 4 and so on. If you want to go backward, you divide by, you multiply 2 here. So here you multiply 2 going backwards. If you want to go the next one, it will be 20 here. See? So main thing is, if you get confused with this, don't worry. All you need to know at least these 2 points. So when we graph this, so when x0 is 10, so I'll just write, if this is 0, maybe this is 10. You put 10 here. And when it is 1, it is half. So half means 5 here. So this is 5. So this is 5. If we put 2, you got half of 5, which is 5 by 2. 5 by 2 is 2.5. So somewhere here maybe. And this is 10. So you get a graph, something like this, and done. Or the best is use the calculator and graph it using desmos.com. Delete all this and put y equals, just to make sure we understand, n times 2 raised to x, sorry, half raised to x, right? Half, close, see? Yeah, beautiful graph here. If you want to know the points, we can pick some points, -2, -1, and maybe 3, and clearly see those points. We get beautiful. Okay, let me take from here. And this 0 is 10, 1 is 5, 2 is 2.5, 3 is 1, and so on. So I hope, so there is exponential decay here. So every time 50% decreases. So from 40, it became 20, so now half of it, see? So the output decreases by half of whatever the previous one. That means 50% drop. So this question is almost similar to the one more example that we did earlier. So what it says, a population of Tucson in 2019 is given 548,000. So 2019 also is like in the beginning. That means in the beginning means 0. The population was 548.1. Okay, and then after that, in the year in 2020, that means from 19 to here, so that means 1 year passed. So 1 year passed, and the population was 551.3. So these are the main 2 points, and this is the same thing. Whenever now, what does this 0 basically means? It is in the year 2019, and this basically means 2020. It helps us to calculate around those years with like 200s. Once you get this point, because this is 0, this is the initial point, initial or the y-intercept. It means when you want to graph like this, when it is 0, if this is 500, let's see if this is 500, so this may be little above, this is 1000, and maybe here. So this is that point. In the beginning, it is 0 is 548.1. So when we model the equation is y is a b raised to x. So this is already a 548.1. So the equation is 548.1 multiplied by b raised to x. So the first point, because it is 0, you already got the answer. But now when x is 1, so now the next is, so this is, next is we'll plug in this part. When x is 1, so when x is, I'll just put it, when x is 1, y is 5, 5, 1.3. So that means 5, 5, 1.3 is 54.54 508.1 times b raised to 1. X is 1. So now all you do is divide both sides by, so this crosses out and you get b equals. You do little math there on the calculator. If you put this on the calculator, you get 1.005838. So the whole equation now becomes this equation now. So the exponential model is y is whatever you have in the beginning, that is 548.1 times, and this b is a big number, 1.005838 raised to x, and you're done. So that's the question. But at the same time, the population continues to grow by the same percent each year, then what would be the population in the year 2030? So 2030 basically means if this is 2000, 2019, this is 19, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So this is 2030. That means how many years from here to here? You can just do the maths, 2019, and this is 21, 11. So all you do is in this equation put x equals 11 and you get y is 548.1 times this whole thing raised to 11. Okay, let's put this on the calculator and see what's going on. So 5838 on the calculator. So let me pull out the calculator. Here it is. So we need to, so 548.1 multiply by open parenthesis 1.005838. So just want to make sure this is correct. 1.005838 and close it and go up and put 2030. So I'll put 11. See, and enter, and you get answer as 584. So you get that answer. So if we go back here, so this will be 584.343, 584.34351 in thousand. So that's the population. That's all you're supposed to do. And hope that helps. Let's take another one. Now, sometimes not always is going to be like a zero. This became easy. What if the question is different? Now look at the next question. Is a little hard.